Okay, so now I'm going to cover when we have some sort of problem, would like to design a circuit or a logical formula to solve. Usually the way we do it is we take the description of the problem, we construct a truth table from the description, and then we find a formula that describes that truth table. Sometimes you can go from the problem directly to the formula if it's easy enough, but if it's a particularly tricky description that doesn't map easily to a formula, then it's usually easy to go through a truth table in between. So I'm going to go do an example here. We want to build what's called a majority circuit. A majority circuit is a circuit where the output is 1 if a majority of the inputs are 1. So we'll make it a 3-input circuit. So we've got a box here, we've got 3 inputs. We'll call them A, B, and C. And the output will be Q. I'll put M for majority. So if at least 2 of the inputs are turned on, the output will be turned on. That is, if at least 2 of the inputs are true, the output is true. And if 1 or less of the inputs are true, the output is false. Okay? So just from that description, it's not immediately obvious how we can create a formula for this. So what I can do instead is I'm going to construct a truth table for the majority circuit, and then from the truth table derive the formula. So let's draw our truth table. So we have 3 inputs, A, B, C, and our 1 output Q. So we list all the possible combinations for the inputs like we usually do. So 0, 0, 0, 0, 0, 1, and we continue listing all of them. In this case, there are going to be 8 possible inputs because 2 to the 3 is 8. 0, 0, 1, sorry. 1, 1, 0, 1, 1, 1. There we go. And now I just list the output. So if there's 2 or 3 1s, I output a 1. If there's 1 or 0 many 1s, I output a 0. So 0, 0, 0, there's 2, so that's a 1, that's a 0, that's a 1, that's a 1, and that's a 1. Okay? So now we've got our truth table. We need to construct a formula for the truth table. And there are a few different ways to do this, but the easiest way to do this is to write out the formula in the form of what's called a sum of products. Sum of products is a term borrowed from engineering, because they use the word product instead of and sum instead of or. But essentially what this means is the formula is going to be in the form a bunch of variables anded together, possibly with negations, and then you separate it with an or. And x2 and not x3, or etc., etc. So each one of these clauses here is going to correspond to 1 row in the truth table. And so what we can do is we can just pick the rows where the output is true and then describe exactly what situation that occurs and then separate each of these with an or. It's not the most nicest way to solve the problem. It won't give you the minimal formula, but it's always guaranteed to work, and it doesn't require like solving a tricky optimization problem. To take this table and figure out what's the shortest possible formula is in general a really difficult problem. It's actually an exponential time problem. So let's just do the sum of products instead. So I'm going to mark the rows where the output is 1, which is going to be these 4 here. And then all I have to do is I have to write out the circumstances when that occurs. So Q is going to be equal to, so this row, this output's a 1 when A is false and B is true and C is true. So this is going to occur when not A is true and B and C. Okay? So that's the first possible option. Or what else could it be? It could be when A is true and not B is true, that is B is false, and C. Or it could be this one, A and B and not C. Or A and B and C. If you've taken, I believe, Engineering 2218, you might be used to a slightly different notation where you just put the variables next to each other if you're doing an and you put a plus sign if it's a or, and you put a bar over top if it's a negation. So you might be used to notation like this. So I'll just write the same thing again using this notation. This notation is a bit more compact for using sum of products, but it's not usually the notation we use in this course. Either one is acceptable when you're doing your assignments, but just be aware that this is usually the notation we'll use within this course. So now you can see exactly why it's called sum of products, because that's exactly what the formula is. It's a sum of many products.